All right, so I'm going to go through our review stations pretty quickly. And again, if anything's confusing, you just let me know and I'll make more explanation about it. So the first one, negative x squared plus 4, it's just going to look like a normal parabola, but it's going to be pointing down and it's going to be shifted up by 4. So it looks approximately like this. And the only points that are really important to be careful about are your y-intercept and your x-intercept. So I know that it's going to take 2 steps to have a value of 4 because 2 squared is 4. So that's a pretty darn good graph. The second one is a cubic graph. And a cubic graph has that sort of S shape. And I see that it has 3 different x spots here. And the first one tells me it's going to hit when x equals 0. The second one, x equals 2, because 2 minus 2 is 0. Third one, x equals 3. And I'm just going to make sure I hit through those dots like that. And this is a decent enough sketch of what's happening. It goes a little bit below and it comes up like that. Oh, my picture's slided. That's not what we want. That's okay. Then the third one is just a quadratic, shifted 3 steps to the right and 2 steps up. So 1, 2, 3, 1, 2. The negative 2 means it's twice as tall and it's pointing down. So it looks approximately like that. And the last one is a cubic with a negative. So this is an S curve going down. And if I plug in 0, I get negative 2. So my curve goes something like this. This value right here you could find with your calculator, or you can see that it's going to be the cube root of negative 2, whatever that is. So that's it for those graphs. Now, finding the zeros algebraically or graphically, we just did the graphs for these 4 ones here. So I know that these ones have x equals 2 and x equals negative 2. Here we had x equals 0, x equals 2, x equals 3. Here our graph was hitting the x-axis at x equals 4 and x equals 2. And this one, it's at x equals the cube root of negative 2. On the other ones, you can just type in your equation into your calculator and find where it hits the x-axis. Some of them are easy, like this one gives, when it's in factored form, it's relatively easy to just identify the zeros. So I'm just kind of going through and writing down what number makes each of those parentheses equal to 0. I can tell x equals 2 does. This is a little trickier here. It turns out that that one could be factored if you remember your factoring skills. X minus 4 and x plus 3. So we get x equals 4, x equals negative 3. And can this one be factored? Yeah, so that one would be x plus 3 and x minus 1. So that one also has some nice factors in it right there. But again, you don't have to know how to do it algebraically if you just look at the graph. Okay, now these are the same graphs as before. So I just figured out that this one is, what was it? X plus 3 and x minus 1. So if you have those two x-intercepts at positive 1 and at negative 3, you know that your vertex has an x value of negative 1, because that's halfway in between. And if you plug in negative 1, you'll see negative 2 times negative 2, which is 4. So the vertex right there is at negative 1 comma 4. That is your turning point. Of course, You can also type it into your graphing calculator and find the maximum. I'm not going to go through each of those right here because we've practiced using the calculator many times. You just type it in, go left bound, right bound, etc. All right, question 4 is finding the A, B, and C values. Some of these are easy, some of them are harder. Here, the A, B, and C values are just sitting right there. When it's in factored form, you got to multiply it out like this. So you'd get negative x squared minus 4x minus 2x plus 8, which ends up being negative x squared, positive 6x, negative 8 because I distributed the negative. So A is negative 1, B is 6, C is negative 8. If you look at h of x or j of x, you can do a very similar thing. When x minus 2 is squared, it means you write it down twice like that. So you go x times x times negative 2, negative 2 times x, negative 2 times negative 2. So x squared minus 2x minus 2x plus 4. So that gets negative 3x squared. That makes negative 4 times 3 is 12. So plus 12x minus 12. So we've got our A, B, and C. The one that's a little trickier is this other one right here. You can find this with your calculator by pressing the stat button, typing in your numbers, and using quadratic regression. Or if you want to, you can set up your 3 equations, because you know that for a parabola, y equals ax squared plus bx plus c. So let's start with this. 0 equals a times x squared plus b times x plus c. That means that 0 equals c. Then we'll use this. 0 equals a times 3 squared plus b times 3. And I'm going to leave off c because it's equal to 0 anyway. So I have 0 equals 9a plus 3b, or take away 3b from both sides, b equals negative 3a, and then last use this, y equals a times x squared plus b times x, and I get negative 2.25 is 2.25a plus 1.5b, and then I throw this piece of information in there. B is negative 3a. So negative 2.25 is 2.25a minus 4.5a because I multiplied by negative 3. That makes negative 2.25. So a is equal to 1, b is equal to negative 3a, and c is equal to 0. So again, you can do it graphically, you can use your calculator, or you can do it algebraically, following the steps I just showed. Now, many of you asked really about numbers 5 and 6. Anytime you read something varies or something is proportional, you use the initial information to set up an equation, and then you use your equation to find the mystery information. Okay, so what we're saying is shoe size of 10, 66 inches. So what we can say is that if y is the height, y is equal to kx. So we're saying here, shoe size, here, height. Of course, we're making a bad assumption that they're going to be proportional. So 66 is k times 10. K is 66 divided by 10. Then the next question says how tall. So we don't know the y. We just found the k to be 6.6. Shoe size of 8. So 6.6 times 8. I guess whatever that is. 52.8. And that's in inches. If we wanted to convert that, we would divide that by 12. And we get 4 feet, 4.4 feet. If you do 0.4 times 12, you could say 4 feet and 4.8 inches. There you go. The distance at a marble varies directly with the square of time in seconds. So d equals kt squared. Varies directly means multiply the square of time. Travels 5 meters in 3 seconds. That means 5 is k times 9, or 5/9 is k. Now, how far means we don't know d. We do know that t is 6 seconds. So we just type in 5/9 times 6 squared, exactly how I right there. 5/9, 6 to the second power. Like that. You get 20. By the way, I feel compelled to point this out, that if something varies with the square of time, if you go twice as long, it's going to go 4 times as far, because 2 squared is 4. You may remember that from doing some physics stuff. Okay, percentage varies with how much it's being used. Okay, so the percent varies with the use. 60% is k times 4. Now, I'm going to be careful here because if it varies directly, that means they both go up together. Okay, so this is actually wrong. I made a mistake. The more you use the phone, the less battery the battery it has. So I'm going to try to set that up again. It has to be an inverse variation because the more you use it, the less you have. So if they use it for 4 hours, 60% remains. So 60 is k over 4. Multiply by 4, and you get 240 is k. So now you use that. Percent is 240 over 6. And you get that the percent is equal to 40. The first way I set it up with the direct variation would mean that you'd have more battery the more you use your phone. That would be nice. That's not really how it works. Okay, so the velocity of a car is inversely proportional to the time. Okay, if the car travels at 5 miles per hour for 4 minutes, then I can multiply by 4 to get my k. And I can set up my velocity equation for 10 minutes. How fast would a car travel in 10 minutes going the same distance? 2. And this makes sense that if you go the same distance and it takes longer, you're going slower. Okay, last one. Find the minimum surface area of a cylinder if the volume is 1200 pi. So if the volume is 1200 pi, then I know that the volume of a cylinder is pi r squared times height. I also know that the surface area of a cylinder is 2 pi r squared, that's the top and the bottom circles, plus 2 pi rh. I got 2 letters here, so that's no good. I'm going to use my other piece of information, the constraining piece. I'm going to solve. If you divide both sides by pi r squared, I can solve for the letter h. So 1200 pi over pi r squared is h. You can cancel out your pi's. You don't have to, but you can. I'm going to grab this and substitute it for the letter h right there. When you type all that, when you do that substitution, you get that the surface area is 2 pi r squared plus 2 pi r times h. You can simplify that if you want, or you can type this into your graphing calculator. If you type it into your graphing calculator, you're going to get some weird looking thing that does something like this. All of this junk over here you can ignore because that would mean negative radius. You'll notice that there is a dip, kind of like a vertex right here, a minimum. you want to find that minimum with your graphing calculator. It turns out to be approximately 8.4. Just make sure you practice using your calculator to find that minimum. One student talked to me and mentioned that it's going to be minimized when you have a sort of square-ish shape. A square-ish shape being a cylinder where the diameter is equal to the height. And that turns out to be true here. I don't expect you to know that fact, but it does turn out to be true that if you have equal height and diameter, that will give you the smallest surface area. But if you don't know that, I do expect you to be able to set up your equations, solve one equation in terms of a letter, and plug it into the other one and minimize the graph. Last problem, similar process, maximum area of a rectangle if the perimeter is 35. So as you set up your perimeter, I just like to call x and y like this. So my perimeter is equal to adding up all four sides of the shape, which is the same as saying you had 2x plus 2y, which is the same as saying the x and the y are 35 divided by 2. So 35 divided by 2 is 17 and a half, which is the same as saying that the y value is equal to 17.5 minus the x. And what I actually care about is maximum area. Area of a rectangle is x times y. Just like in the cylinder one, substitute that right there. So area is x times 17.5 minus x. You graph that and you find the maximum. This one is nice and easy to graph because, like I talked about earlier, the zeros are x equals 0 and x equals 17.5, meaning if I have x equals 0 or x equals 17.5, I'll have 0 area. The shape in between them is a parabola, so the vertex is going to be halfway in between 0 and 17.5. Half of 17.5 is, I guess, 8.75. And if I plug in 8.75 to my area formula, I do 8.75 times itself, which gives me 76.5625. So this is the maximum area. It's measured in terms of meters squared. So there you go. Those were all the review stations. Let me know what you need extra help with. Happy to do it.